Hey everyone, my name is David Bowman. I come here every once in a while and try to shill people to use Effect. I think I've converted 0 people in my 2 years of doing this.
That's not true.
One?
I've converted half of someone, but I've been pushing Effect code to production. What I want to talk about today is kind of something probably more in theory than it is. It's a repository that I made. So here's the story. Effect version 4 is coming out soon. It's currently in release candidate. It's already very strong. Like there's not really expecting any bugs between now and then. It's worth checking out. And they have some new APIs. And so I thought, like, why not be a good Effect boy and play around with them? And they have this new API called migration. And they have a bunch of other little libraries around there around using SQL. And I wanted to kind of show something maybe a little bit more theoretical about what could be done and why it's kind of cool. I also think, maybe let's ask some questions. How many people here have ever used a database? A lot of people. How many people here have ever created a database? Not writing your own, but use Postgres or something. Okay. How many people here have ever written migrations? Okay, this is almost everyone, so this is good. How many people have ever written a migration test? No, you have not. I have invented a novel idea called a migration test. It never existed before now. Now, I do believe that it must exist, but I've never heard of anyone doing it. And I want to show you how you can use Effect v4 to write migration tests. Let me give you a quick example of why it might be important. I create a user v1. So I built an application 3 years ago, and I have some type of schema that goes into my database. But now, I'm on version user v17 3 years later, and I want to ensure that people who return to my website don't break. That's the entire theory. How do I ensure the safety of my schemas over a long period of time? Usually, what we do is we just wait for errors, and then we fix them. And that's okay. Like, that's the rest of our job. But now we can sit there and spend a lot of time coding cool things. Let me show you what I've done. And I have a demo as well, which is pretty cool. Let me kind of give you the general theory of this. I say test it, that's not really strong. Oh, by the way, you can visit the website at the end. You can download the repository and you can play with it yourself. It works completely locally. Generally, when building some type of full stack application or even just a back-end application, there is something which I would call drift. There's going to be drift between your tables and then drift between your schemas. So if you're using something like an ORM, like Drizzle or Prisma or something like this, you have your users table written in Drizzle or Prisma TypeScript, and then you secretly have your SQL table, and then every single time you make a migration, you pray that they stay aligned. So here's like a little example. Over here is what it would look like in Drizzle. Over here is what it would look like, in this case, Effect. So here with an Effect, I can use Effect schema, create unique UUIDs, non-empty strings. I can give regex patterns, dates, null, or whatever. So generally, whenever you build a database, there is drift between your actual database and your schema. Yeah?
Is it too early for questions?
No?
So what are the, who are the two main competitors to Effect?
Me. No, I don't care. I have no idea.
You have no idea? Okay.
In the TypeScript realm? I don't know. There are no competition for Effect. I'll look at the camera when I say it to the Effect core team. There's no competition for Effect.
Like Zod maybe, or?
No, not at all. Because so one of the major differences is that this also handles encoding and decoding through the network boundary. So I'm guaranteeing types encoded and decoded, and also transformations, through the back end. Maybe I'm trimming or cleaning. Maybe I'm moving it to something else, and then the front end I'm also handling validation. Where Zod only handles front end validation, it may be schemas through something like a form. It won't necessarily decode or encode through the, like for an example my peers, I have a user here, but now I'm working with 7 external services. I have, I have a pharmacy, I have a payment processor, I have blah, 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 and all of which I need to send user data, and I need to transform it to meet their type of schema. This allows me to have some grand schema that I can then transform, encode, and decode through multiple boundaries and ensure that there's only one. Where Zod is just, did they type into the form something correctly? Okay, so what happens? You use something like Drizzle, and then you use something on your side to manage your schema. Maybe you don't use Effect, you use Zadly, and you use something like a TypeScript interface or whatever. But you have to write your migrations, and inside your directory, inside of your current working directory, there is probably 400,000 lines of SQL that we just don't look at, and you can't delete them or else you'll destroy your application. So you just live with 0096 or something like that, and you can never delete them. You just depress them. They're just there forever. Never re-baseline your database. It's not worth it. You have to be mature and accept that more lines of code is fine. Okay, so what I'm trying to say is instead of having drift, between your ORM, which is kind of more emulating the side of your database, and the schema that you use on the front end, what you can do is sit there and just use something called effect. What you can do in effect is you can do something called creating a model. A model is something that emulates SQL. So in particular here, we're modeling both Postgres, but also creating front end and back end encoding and decoding validation. So we might have a model generated. This says that when I insert it, I will automatically generate a UUID. Effect uses something, yeah. Zoom in, yeah. So effect uses something in Schema called a fast checker. Has anyone here used fast checking before? Okay, no one. Fast checking is when you take a schema and it uses a certain has anyone used Faker.js before? Faker.js is kind of like a fast checker, but you can sit there and add predetermined lists. A fast checker takes a schema and produces arbitraries directly for testing. It's very nice in testing. You might sit there and you might have a schema that says, I accept first name, or let's say address. I accept an address that must be a string. It has to be less than, let's say, 20 characters. And whatever. I sit there and I create a whole bunch of validation rules about it. But what I can do is I can then sit there and create fast-checked arbitraries, run 10,000 tests, and then I'll notice when it produces something that's 25 characters, it fails my external services. The point being is that you can have your central schema create arbitraries based on your internal validation rules and run smoke tests against your external services to find errors before they occur in production. That was a cool sentence. It's a really powerful, it's a really powerful sentence. It's saying, how do I define schemas internally for myself and ensure they work with my external services, which are all garbage, right? Raise of hands, who's worked with an external service? They're all trash, including the ones I built. If you use mine, it's also garbage. My documentation's way better though. So, but the point being here is I can sit there and I can create something, instead of just a schema, I can create a model, something which creates zero drift between my SQL and my, what would you call it? My internal schema that I use. Now something that's kind of obnoxious here, again, this is theoretical. You'll see here we have a user V1 through V4, kind of ugly, kind of hate it. But it's the way it is. So here for user V2, here we had a V1, we had an ID, first name, last name, email, and then a whole bunch of timestamps. And then over here, V2, we add a phone. V3, we decided we didn't like the phone. And then we decided better off, we're just gonna use magic links, right? And then V4, we decided actually we're gonna separate the email into two different things. But the point being is that I now have a most up-to-date version user V4 schema. There's no perfect way of doing it. You still have to create some sort of versioning. But instead of doing it through migration files, you have it through testable programs here. Like user V1 here is a schema that can be tested. Let's continue. So first I want to show you some of the powerful, cool things about effect. Is this a good example? We can do better. Here's one thing though. Email, I can sit there and I can check, does it follow my email pattern, which I forgot to include above here. Imagine some regex that's an email. Joa probably knows exactly what is off the top of his head. If it fails, this is the front end validation. It's important to know that this is a single shared schema between your front end and back end. So you can pipe this in through using something called effect atom, using people who use TanStack form or whatever it is. This kind of does the same thing. You can toss your schema on the front end, so when someone types in a non-email address, you control your front end validation message the same way that you would your back end validation message. And also here, this is where I'm saying you can create arbitraries. This tells the schema that when I use the fast checker, I want you to create an arbitrary in this form. In this case, I'm just using Faker. Grab an email, 2 lowercase, blah, 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 fine. One schema, in this case, has 4 different jobs. Front-end form validation using effect atom, encoding and decoding through the network boundary, whether it's your API, whether it's queries, or sorry, what's it called, queues, workflows, WebSockets, whatever network boundaries you define, it can encode and decode through. You can do Faker-based arbitraries. This is good when you want to seed 10,000 tests into your database and you don't want a whole bunch of gibberish, you want things that look like actual names. And you can sit there, how they do that. Okay, and you can sit there and do property tabs times 1,000. Let me give another little example here of where we can use effect. You'll see here that we can define the decoding and encoding. Like decoding, we sit there, we transform. So meaning when it comes through the form, we strip it to digits before it goes into the database. And when we get it, we sit there and we just pass it through, whatever. We'll handle the front ends on that side. We'll add the parentheses and the line that makes phone numbers look pretty. We don't care what it looks like on the front end. We're just creating the schema. We create our pattern, and again, I should probably have condensed this a little bit. Gotcha, okay, worry about that. Read it yourself. Now I want to talk about creating migrations. Here's what the migrations look like. I'll show them to you over here. I don't know, is it too hard to read?
No.
Okay, I haven't, so nothing might work here because I don't use this computer. But you'll notice here is my migrations are using something called Effect SQL Client. I'm writing pure SQL. It's not Typesafe, but it is a program. It's exporting default, so I can't perfectly show you. But this does have a type that's usable. Here we add the phone. Here we sit there and we split the email, whatever. You can write JS doc or let Claude do it for you as well. But the point being is that you write your migrations now into an effect. It becomes an effect program which is fully testable, which is super cool. Because usually when you write migrations, it's just SQL, and you have to sit there and run it. If it works, cool. If it doesn't, then you have to roll it back. Here it's an actual program that's testable. What did I write down here? Oh, that's the same thing. It's a little prettier here, isn't it? Yeah, it's a little easier. Maybe we'll just stay here. It's the same thing. Okay, so now I want to talk about a new thing in Effect v4. Effect v4 is something where you can create a migrator primitive. A migrator is something that runs your migrations, whether it's from the file serve or whether it's from files individually. The API looks something like this. I first create my PG migrator client, and then I run my migrations. In this case, it's just from tmp.schema. Do I have it here? Yeah, okay. Here it is. So, and then here, you can see it just secretly does actually, compile down to actual SQL. And then here we load whatever. You just create a migrator client. You can do it either from the file system, which is very nice. Like this is what you would do, for CI/CD, or whether you want to run all your migrations. But you can also do from record. Like for example here, where it's kind of cool. I can sit there and create a program that says run migrations, from record 001 create users, then insert a user, and then I could run the remainder of my migrations. This is kind of the core of my theory of something that's kind of cool. Can I create a V1 user, matching my user V1 schema, then run the additional migration files and ensure that it passes my current tests? Because what I don't want to do is I build a lot of startups. So companies hire me to say, David, we have an idea, we need to find product market fit. But they have no idea what their users like. So they say, David, build something. And I build it and I ship it. And then 3 days later, after spending 30 grand on marketing, I say, wow, this does not work at all. Change everything. So we want to be able to change everything to find product market fit, so we can go to market and give everyone some cash. But we're afraid. What about those people who tried signing in who created their first account with us last week? Are they dead? David, nuke their accounts. No, we don't need to. We can now write something called a user v2 schema, and we can run migrations directly against them. So that means that when I actually run my v2 and my alters and whatever, I'm transforming a user v1 into a user v2, and I'm ensuring that they pass my current unit tests. Now, because I am a psychopath that believes in pure functional programming, that means that all my internal services and external adapters have no side effects, which means that my unit tests have 100% coverage, and they're beautiful in every way. So the point being is I can take my user v1, insert them, run my unit tests against them, and then migrate them to user v2, and then sit there and run my unit tests again, and theoretically, if they pass, they will have no issues. That means I've altered all their data in the database. This is great for me. It's how I can sit there and say, no, you didn't burn through $100,000 in marketing dollars between user V1 and user V2. We could salvage 80% of them because of there's probably other issues. This is great for startups. The issue is that it's a lot, right? Okay, so how do we test it? I kind of want to show you my repository. I only have 9 more minutes. I did something cool, which I've never done before. I'm not sure if you noticed, but there's something called test containers. Has anyone ever used the library test containers? Only one. That's more than I thought. Test containers allows me to, in code, create an actual container. For example, this is a Docker container with Postgres in code. Let me show you, it's super cool. do a test setup PG container. This is an actual container. It's an effect service that owns a lifecycle of throwaway Postgres container. Meaning that when I'm testing this, I'm not testing it against some theoretical schema that I've created. I'm actually inserting into a temporary Postgres. No Docker creation, you know, that you have to be super smart at Docker to like ensure that it builds in less than like 500 hours. You know, like it creates a temporary Postgres container where we run migration 1. We actually create user v1. We run tests that get directly against the database. And then we run our additional 3 things, all within an actual container that's thrown away. I'll show you. Now this computer has, I think, 4 gigabytes of RAM. This is like a 5-year-old Surface Pro. So like, it might take a minute for these to run. At home, they all ran in 15 seconds. And something to kind of show you around my tests. Where is it? The tests, I just call them migration tests. For example, here one, like checking idempotency. Like they run a decent amount of times, I think. Maybe not. Like this one runs 5 times. This one runs 5. Did I lower it that much? At one point, I think I lowered it for this laptop. I was running them all like 1,000 times each, and it took like 15 seconds on my other computer. So here, over here, it took 22 seconds. It would be faster on anything else. But here, it runs through all of my tests very clearly, all through a real, you know, Postgres container, which is awesome. It's very, very cool. So there's also here, we have our container, we create our DB level, which just takes in the container, it sits there and it runs, you know. There is this kind of nice little cool thing in effect called the PG container where I can sit there and make transformations knowing that like, hey, I'm in JavaScript gonna take my strings, I'm gonna have to do snake to camel or camel to snake, whatever. It's just encoding, decoding through the external database service. But we call it transforming for databases for something. And then I have some little thing which just says reset. This is like would be my before all or before each within a test, which just says basically wipe my database and run it again. Can anyone tell me why I run my tests 1,000 times?
To see if they're flaky.
There's 2 reasons now. Not only are so flaky. Well, I have a belief, and this is a religious belief of mine. My religious belief is that if you write pure functions, that they are fully testable, and if you write schemas that use non-artificial arbitraries, meaning that they're in line with your true encoding and decoding process, that you will discover actual errors before they hit production. That's my belief. And flaky tests. Flaky tests are tests which I fix, because that just means that my validation rules are not correct. Like, I should be like, if for some reason one of my services can produce an address that's greater than 35 characters, but my internal services require something less, I need to either trim or cut, or I need to sit there and repair my service. That's not a flaky test. That's a production failure that will happen, because sometimes users, you write Google Places API and you say use the long text or something, you can easily get over 35 characters. But the point being is, by having a single source of truth as my schema, by using fast-checked arbitraries and burning them through functional programming unit tests using a Postgres container, I can actually check for real drift between my schema and my database and find real production issues before they come. How exciting? Is everyone excited?
Yes.
Okay, cool. So no bespoke test on it, it's just layer composite. I wrote most of this, by the way. This is my site. If you read it last month, which no one did, this is very different. I rewrote this after actually building the application. I learned a lot doing it. So here I just give some examples of tests, whatever. Idempotency, I want to ensure you know that I can sit there and not run the same migrations over and over again. Like for example here, if I do a first run of migrations and I run them all, a second one, you'll see that I can get an expect.length of my second run to be 0. It will not sit there and rerun migrations, which could lead to namespace issues, but just better organize your migration files. A V1 row survives transform migrations. This is kind of the test that you can write. It's very cool. We sit there and we reset our public schema. So this is all exists within the fresh DB layer, which encapsulates our Postgres container. So this is a real database. We run migrations v1. We const yield v1 repo, which is our model for the v1 schema. We insert it. We sit there and we grab the domain of the email. You might not remember, but in our v4 schema, all that we did is we separated the original local and the original domain email. There's no real reason to do it. It's just, it was easy to write. And so I sit there and I create it. I separated out what it looks like in V1. I run my additional 3 migrations, and I basically just check to see that they're the same and to see that the delete at is null. And I run it 5 times. And it passes. How cool is that? I've now tested the V1 schema, gone through the migration files, and it still works. This means that the $100,000 in marketing wasn't lost, which means I can charge how much? $100,000 more. That's the whole point here. I'm not joking. That's why we do it. No? Like, is anyone doing this for fun? Migration error as a defect. Does anyone know the difference between a defect and an exception? Cool. Don't. An exception is something that generally happens in the runtime. It's something that I sit there and I catch and I handle. A defect kills the thread or the application. So for example, let's say that my migration fails. Do I want it to continue? No, it dies completely. Or I sit there and I catch the defect and I roll it back. But the point being is I want to separate between runtime exceptions and defects. Migration error runs as a defect, which is very nice. It's a little gotcha, for everyone who's going to go to home and do this themselves. It's important that you know that if your migration fails, it's a defect that you can catch, you can handle it with an exit, and you can expect the exit to have a cause. Everyone here knows what the exit primitive is? Excellent. It was an exit is a way to catch a defect and determine the cause. It's just a basic object of typing for defects versus exceptions. I guess, I don't know. We're not a lot of Haskell engineers.
Is exit built into JavaScript?
No.
Oh, okay.
No, it's what the effect core team decided that TypeScript should look like Haskell and other functional programming like Scala 3 in all of its beauty. Okay, so what this pattern actually does for you. You get defect level failure signal, so you'll actually be able to test your migrations run against all your users, and you'll get a true defect. You won't get an oopsie daisy that you had to properly name and catch. You'll get a true defect. Sorry, it died. Your migration completely died, which ensures what? That you have version schemas with no drift. You have the ugly user v1 through v4. I don't know. I guess there's some give and take somewhere. You get to write migration tests, which is in theory really cool. I should mention this is more like research based and probably real. I can't imagine ever really doing this for an application. But no, I mean, this is a tremendous amount of work, no? It's a tremendous amount of work. I think maybe if I sit there and write some more, I could find a clean way to do it. But the reality is that I think the drift between an ORM and the database is relatively acceptable, and the migration generation's generally strong enough. But I do think that there's probably some cases, maybe with mission critical data or very large things where there's value. I think still it's very complicated. This is hard. Right? It isn't out of the box beginner stuff. I think there's value here, but I can't yet fully express what it is. But it's good to know it's possible, yeah.
Can you point cloud at it, let it rip, and then
No,
come back
absolutely. These are experimental APIs. It's a novel idea. I've created it. I call them David Bowman tests, as you should. No, I call them migration tests. But you have real engine layer composition, which is nice. You're not booting up a Docker container and running tests against it, or booting up 1,000 Docker containers using something that Riley might be interested in, which is an actual test container that can run purely in code, and on a terrible computer, can run relatively fast. My computer at home, I was doing 1,000 of each of these in 15 seconds. And that's 8,000 tests against a container, which is pretty clean. Yeah, that's
My
it.
agents write all my code for me. Do you have a skill?
No. So my recommendation is if you want to use a library you're not familiar with, create a Git submodule directly into your repository and tell it to look through it for best practices. If your library owners write good libraries, they'll generally have good documentation and a testing folder that shows exactly how their stuff works. Effect does this exceptionally. It's built with purpose for it to be used by LLMs. So just add it as a Git submodule. It's okay. You won't spend too much money on GitHub, and you'll get a lot of value out of it. In my personal cloud planning skill, I just say if you're using Effect v3, look through my submodule Effect. If you're looking through Effect v4, look through Effect Small, which is their current release candidate for 4. Yeah, right.
Does that look through the whole repo though? Is that
Yeah, it's a whole repo.
okay? Because that'd be kind of expensive process, right?
Nope. It's well organized. Yeah.
So going
It's
back,
worth it. I mean, if it is.
Yeah.
to this
Like, what am I
gentleman's-
gonna do, work harder?
Or
That's
like,
the other
like,
option.
for the effect example, right? Is like I would assume it's like a big mature code base. Like it'd be better if they had
It's not that big,
distill.
it's surprisingly small.
So going back to that gentleman's question, I don't know his name, guy in the white shirt with
Smart
the,
guy sitting up front, looking at his phone, yes.
hey, he still has no knowledge.
He's focused, he's over there making money.
I am. Just made $10.
Anyway, so his question was
A little
like
more interesting.
the competition, and I think this isn't so much about effect specifically, it's about this effect sequel, and it's an alternative to Drizzle.
So what I'm suggesting is, so here's a reality I need you to accept. Does anyone know the difference between coding an internal service between an external adapter? I'll tell you. An internal service is something that I fully control. An external service is I'm trusting other people. So how do I test an external service? What I do is I build an internal test adapter that matches the exact same implementation, or the exact same, parameters and outputs of the external thing, and I test my test service instead. I don't actually need to connect to the external service and do all the mumbo jumbo. I just know I'm going to either get a 200, 400, 500, and it's going to have this type of JSON. And I'm going to encode and decode against that in my schema. But the point being is when I write internal services, I control fully. I only need one file. I can test against my file because there's no side effects just as well as I can run in my software. When there's external services, I have to write an internal adapter and then also my external implementation. The reality is that when you use a database, your database is an external service. It sucks. You want to pretend it's not, that, oh, it lives in my VTS or it's D1 or whatever, but it's an external service. And it has different, and you will always have drift between the database schema and your own. Like, it lives outside of it. You can switch databases or database providers. It's really an external service that we convince ourselves is internal. What I'm saying here is it can truly be internal when it runs completely off the same schema that your runtime does. And so I'm saying, it's not a replacement, it's better. It's a single schema with no drift between your database and your internal software, which means that there can be no drift, as long as you can create user v1 through v7, which is obnoxious.
I guess a follow-up question that's just like my personal.
We version our APIs anyways, right? Everyone here versions their APIs?
Sure. Right.
Yeah.
So let's say, and I'm not sure if Drizzle can
And we
do
have to
this.
go in a second because Riley has.
Oh, okay, my bad. But like when I've done this in like other frameworks like Python or something, like a lot of them have the ability to migrate to a specific migration. So if Drizzle can do that, like, couldn't you achieve the same effect doing it like that?
The issue is I can't test migrations. I can sit there and write bad migrations, or I can sit there and add tables or delete tables from my main schema and then fail new or old users. What I'm suggesting here is here's my argument in a sentence. When you update your database, you can create failure points for old or new users. What I'm suggesting is by using the primitives within effect, you can test the changes to your database and how it will affect those users before you ever push it to production.
Could this be a product for like certain incubators or sell it to the government?
It's a product, it's the issue with effect in general, is no one wants to do this other than me. Like, how many years do I have to come here and tell people that they can write elite production code and no one does it, right? Like, yeah, the tools are out there to write awesome stuff, but no one's gonna do it, especially the government. They don't pay well. But yeah, I think so, right? Like, didn't Biden end like TypeScript? Don't we only write in Rust now? Like, soon it's only effect, right? Like, that's what's next. Nah, I think there's endless value in this. I think it just requires, like, I work as a freelancer. I have no teammates, I have no employees, I have no subcontractors. I just write code until I die from a heart attack in front of my computer, and it's a lot of work. It'd be nice, if there was other people that did it. But that's my theory. You can go to my website, I'll post it later. There's this whole wonderful article. You can read all my other articles well. Inside there's a GitHub repository where you can sit there and read the README, run it yourself, and and get excited. If anything, be motivated to like